From our very beginnings, Buffers USA has been a supplier of twist locks to the transportation industry. Not only have we supplied industry standard designs, we have also been an innovator of many new and unique designs. Some are designed for an individual customer's special application. Others, like the height-adjustable twist lock, are designed to solve industry problems, in this case, to overcome the camber on aluminum flatbeds, so containers can be carried on the flatbed. To ensure we would always have a reliable, steady supply of twist locks, Buffers entered into a joint venture partnership with an experienced Chinese supplier over 12 years ago. Once a design is finalized, a prototype twist lock is created and tested to ensure it meets our customers' demanding specifications. Since the main components of a twist lock are made in a casting process, we take great care in this operation. The first step in the twist lock casting process is the manufacturing of the tooling. Our Chinese partner has the necessary experience and skills required to design and manufacture the aluminum tooling for the lost wax precision casting process. The lost wax process allows us to cast without a draft, but it does require skilled engineering to design the aluminum tooling that is needed to make the wax copy of the part to be cast. Once the aluminum tooling has been produced, it is used to make wax copies of the part to be cast. Melted wax is injected into the tooling and then cooled in water. The skill in tool making is to make the tooling so it can be taken apart quickly, but without damaging the wax model. Once the wax model has been released from the tooling and cleaned, it is attached to a wax rod that functions as the filling gate. Several wax copies are attached to one filler gate to create one cluster of parts that together will be poured as one casting. The principle of the lost wax casting method is to create a hard and heat-resistant mold that has an inside cavity that's identical to the desired shape of the finished steel part. The next step in the process is to coat the cluster of wax parts by dipping the wax cluster in a semi-liquid chalk and clay slush. This dipping process is repeated until a thick enough shell has been created around the original wax profile. Once the shell has dried properly, the covered wax cluster is submerged in boiling water to melt the wax. The melted wax floats to the top and is collected for reuse. The mold shell cluster is removed from the hot water and allowed to air dry. After a few days, it's placed in a furnace to cure at high temperature to achieve the proper hardness, strength, and heat resistance. The mold shell clusters are removed from the curing furnaces and are now ready to be filled with molten steel. The mold shell clusters are placed on the floor close to the steel furnaces. During the preparation of the melt, additional materials such as alloys and carbon are added to the melt to meet the requirements for the specific steel grade. Up to 3 tests with a spectrometer are sometimes required to ensure the melt meets specifications for the required steel. Once the melt is approved, it is released for pouring into the mold clusters. During the pouring process, 2 keel or test blocks are also poured for each batch of mold clusters. These keel blocks are then cut into 3 test specimens. Only when these samples have passed the required chemical analysis will the batch of poured rough twist lock castings be approved for breakage from the cluster and heat treatment. After pouring, the mold clusters are air-cooled. All batches of mold clusters are then moved to the breakage yard. At the breakage yard, only mold clusters from approved batches are now broken apart. Individual castings are cut away from the filler gate, and any remaining gate material is ground away before each approved batch of castings moves on to heat treatment. Proper heat treatment requires precise and consistent temperature and time control. After heat treatment, castings are cleaned in a blasting or trumbling process. Samples from every batch then undergo a second round of testing for yield, tensile strength, elongation, and hardness. Once the batch is released, it moves on to machining and surface treatment, either dip painting or galvanizing. The cast parts, together with other components, are then assembled into the final twist lock. The twist lock assemblies are function tested before being released for shipment. Buffer's involvement in every step of the twist lock manufacturing process is your assurance that the twist locks you receive from Buffer's USA will meet your demanding needs.